So like I have said, this project has provided us with a comprehensive grasp of the complexities inherent in the intersection of time series data and neural networks. So this has provided us with foundational insights based on the building of simple RNN model, building the LSTMs and redesigning the LSTMs and comparing the network performance for the LSTM and the redesigned LSTM models. And so the experience while learning with the models is very challenging. And these experiences include model comparison, comparing the simple RNNs and LSTMs, and hyperparameter tuning, which results in adjustment to learning rates, batch sizes, and sequence lengths. These are all conducted in various training and testing models, and these are to be trained and tested personally, uh, which has to be personalized for each data set, and it has to be trained and tested. And the challenges involved in model training, which are usually overfitting and underfitting, and ensuring convergence for more complex structures and architectures like LSTMs, and the forecasting of real world data, which is transitioning from synthetic sine wave data, which we have first used, to the real world time series data, which we are using now, and where we have gained various experience in where forecasting and testing the models on diverse and challenging data sets, and iterative redesign process. While we have redesigned the LSTM network in part 5, where we have added one more LSTM layer and one more dropout layer, which has significantly improved the performance compared to the network 1, and which where the batch sizes and the dropout rates and also the input size has to be rigorously monitored to avoid the time lags and hindering the efficiency of the model. And the learnings from LSTM include the improved temporal understanding and the LSTM architectures and building and training complexities of the LSTMs, and also the dependency handling of the LSTM. And learning from the simple RNN include sequential pattern recognition, the vanishing gradient problem, and also the problems associated with the simple RNNs and the basic RNN architecture, and also the hands-on building and training. So these are all to be monitored and hindered based on the designing of the models like RNN model or LSTMs associated with the RNNs, and the addressing of the challenges is to be mainly configured based on the epochs or based on the dropout rates or based on the hidden layers, which are to be carefully monitored to address overfitting of the data or underfitting of the data or gradient problems for each weights and threshold for each node. These foundational insights acquired in all the parts of the project, culminating in the conclusive performance evaluation in part 6, which is comparing the network performance for the LSTM and the redesigning of the LSTM architecture. And this has provided us with the help of there should be a trade-off between the model complexity and computational resources. While the network 2 has more computational resources, The significant rise in efficiency of the model has to be carefully monitored to see whether increasing computational complexities is beneficial or in the long run has to be decided. Thank you so much for giving me a chance to present the final project of the RNN. Thank you so much.